What if I told you that right now, there might be invisible tunnels connecting distant parts of our universe? Shortcuts that could let you travel billions of light years in seconds. Here's the thing that'll blow your mind. Wormholes aren't just science fiction. They're actually predicted by Einstein's equations, and if they exist, they could change everything we know about space travel forever. Without wormholes, we're essentially trapped in our tiny corner of the universe. The nearest star? 4 years at light speed. The center of our galaxy? 26,000 years. Other galaxies? Forget about it. We're talking millions of years. We'd need thousands of generations just to reach the interesting stuff. But what if there was a cosmic cheat code hidden in the fabric of space-time itself? Back in 1935, Einstein and his colleague Einstein-Rosen discovered something incredible buried in their equations. They found that the geometry of space-time could theoretically create bridges, connecting two completely separate regions of the universe. Imagine space-time like a piece of paper. Normally, you'd have to travel along the surface from point A to point B. But what if you could fold that paper and poke a hole through it? Suddenly, you've created a shortcut, a wormhole. These aren't just mathematical curiosities. If wormholes exist, they're actual physical structures made of warped space-time itself. But here's where things get crazy complicated. Every wormhole that Einstein's equations predict has one fatal flaw. They collapse the instant anything tries to go through them. It's like trying to keep a soap bubble stable in a hurricane. The wormhole's own gravity wants to crush it shut faster than light can travel through it. To keep a wormhole open, you'd need something called exotic matter, material with negative energy density. Think of it as anti-gravity on steroids. This stuff would need to literally push space-time apart from the inside. The problem? We've never found exotic matter anywhere in the universe. It might not even exist. But wait. Quantum mechanics throws us a curveball. At the tiniest scales, space itself is fizzing with energy fluctuations. Some scientists think these quantum effects might naturally create microscopic wormholes, smaller than atoms, constantly popping in and out of existence. So where does this leave us? Scientists are actively hunting for evidence. If tiny wormholes exist, they might leave detectable signatures, bizarre gravitational effects, unexpected particle behavior, or even signals from the other side of the universe appearing in our backyard. The most exciting possibility? Some researchers think black holes might already be connected by wormholes. When you fall into a black hole, instead of being crushed, you might emerge from a white hole somewhere else entirely. It's still highly speculative, but it's not impossible. And here's the kicker. Even if natural wormholes don't exist, some scientists think an advanced civilization might be able to create artificial ones. We're talking about engineering space-time itself, but the physics doesn't completely rule it out. Think about what this means for humanity's future. If wormholes are real, and we can figure out how to use them, we wouldn't just be exploring our solar system, we'd have access to the entire universe. Different galaxies would become as reachable as different continents. We could witness the birth of stars, explore alien worlds, and maybe even discover we're not alone. But even if wormholes remain forever beyond our reach, they've already changed how we think about reality. They've shown us that space and time aren't fixed. They're flexible, malleable, and full of possibilities we're only beginning to understand. The universe is stranger and more wonderful than we ever imagined. What other cosmic shortcuts might be hiding in Einstein's equations? If you want to explore more mind-bending physics that could reshape our understanding of reality, hit that subscribe button and let me know in the comments. What would you do if you found a wormhole? Where would you go first?